Okay.
You can start, please.
Hello, everyone. Very happy to welcome Giorgia Lodi at the MaLGa seminar series today. Giorgia is a permanent technologist at the Institute of Cognitive Science Technologies of the National Council of Research, CNR, where she works on data management and interoperability, among other things. She has worked for many years as a consultant for AGID, Agenzia per l'Italia Digitale, with a focus on semantic web and linked open data. And today she's given a talk on meaningful data and semantic interoperability. And I'm really happy to have her here virtually, unfortunately. And I hope it's the beginning of a very fruitful collaboration, hopefully. So thank you, Giorgia, for being with us.
Thanks a lot, Annalisa, and thanks for this invitation. I'm very glad to be here. First of all, just some notes before starting. This is not a very mathematician presentation, let me say, or something like that. But I would like to present you the works that I've been doing and we are doing at our laboratory, which is the Semantic Technology Laboratory of our institute. So just to start, these are the people in the laboratory that, by the way, I would like to thank all of them because they also provided me with some inputs for this presentation. You may imagine from the picture which are the PhD students. Definitely, I'm not a PhD student, unfortunately, but yeah, these are all the people, authors of works that I'm going to describe to you with today's talk. So the idea of this presentation is to give you an idea of what is going on, or what I tried personally also to push, especially in the public sector. I would say with no much success so far. So because of many reasons. One of the first reason is that in the public sector we have this kind of let me say scenario to deal with. Okay, so we are still, after many years of discussing about interoperability, struggling in, getting these main databases of our country working perfectly in an interoperable way. When I mean interoperable, I mean taking into account all the different levels of interoperability. Well, there is the legal interoperability. This is another issue actually that we have, but also organizational interoperability and semantic interoperability and technical interoperability. We are still in the phase depicted in this slide. I mean, we are very nice in doing bilateral agreements between different organizations in order just two databases to connect with each other. But then we have very nice islands, let me say, around there. And so we have many issues. Also, when we have to produce, let me say, public services, because we are not able indeed to deliver very sound, let me say, public service where the data are correct, where the service is easy to use, and so on. And then there is another big issue that I observed in many years working in the public sector, but it's not probably only the public sector. This issue can be also in the private sector, to be honest, in this slide. But then there is the other issue that is the data quality that we have. And so here I have some examples of real data that I used to work with over the last years. And, you know, when you have to deal with this data and with these examples of low quality data, then it becomes a mess also to apply very nice research advances, let me say. This is an example of, by the way, a very important national database in which you can find many different ways to specify that a value doesn't exist. So we have an address column with and these are all the possible value that I found to say that there is no value, like null as a string, like 5 spaces, okay, I don't know why 5, but it can be some Kabbalah, I don't know, or something to be indicated with the space between the 2 words, in Italian obviously, or otherwise the underscore between the 2, or 0, or dash, and so on. But in the address column, I also found like postcodes or telephone numbers sometimes. There is no definitely control here in this case of the quality of the data that we have in input. Also, there is this example of name and surname columns. Once again, different way to not to specify something, probably here for privacy reasons. But if I continue, this is another example that I found available. Everybody can find these data sets, okay, by the way, because they are open data sets, so they can also be reused for any purposes. In this case, there is this column that is called state 01, okay. Probably if I can tell you, if I tell you the context in which this data set deal with, then probably you can arrive to some conclusion about the semantics, okay, of this column. This is the data set regarding accommodation facilities. So probably I deduced that the status column means, well, I don't know, active or not active, or open or not open, I don't know. Really, I still needed to understand what does it mean. Or this, once again, looking at these nice data sets that we have about accommodation facilities. Here there are some examples of mismatches, okay, in terms of semantics. For example, here, this is a data set coming from one region. They have these 2 columns, okay, one is called category and the other one classification. So in the first one, there are just 2 value, okay, like hotels and complementary hotels or something like that. And then there is the classification where you have the different types of hotel, okay, like hotel 2 stars, bed and breakfast, and so on. But then if I take the same data set of another region, I see a column that is called the category once again, but the value are different because here there are stars, 3 stars, 2 stars. Then there is also something completely different, okay, that is not the classification of the stars, but it's the same value of the other column that is called typology, where there is the classification of the different type of accommodation facilities. So, you know, a human being can understand that probably there is like a connection between these 2 data sets, but for machines, it's becoming more and more difficult, you know, to do like a comparison. This is a very recent example, once again, speaking about data quality of the data that we manage as also as country, because here we are speaking about data set coming from our public institutions. So this is the data set regarding the vaccines, okay, that is published by the government. So just last Sunday, I think, they changed the name of one of the vaccines provider. Instead of AstraZeneca, they put Vaxzevria and then brackets AstraZeneca. I don't know why, because Vaxzevria seems to me the name of the vaccine itself. The provider should be AstraZeneca. So here probably I see also a problem in terms of semantics, because in the other case I have Pfizer BioNTech, which is the name of a provider, not the name of the vaccine that is called in a different way. But here there was a trouble here for all the users who developed application based on this data set. They had to change everything because that string, this is a case of a string, changed at a certain point without no advance communication of that, okay? So here what we have that, for example, here we don't manage codes associated with the vaccine provider. We have just strings. And by the way, we have many columns in this data set, how many vaccines or vaccines providers we have on the market. So if there are other vaccines arriving, we will add new columns changing continuously the schema. So meaning changing all the application, insisting on that data set. And here there is one of the big issue that I still see in the data that we have. There are a lot of hidden knowledge, which is represented as unstructured text strings rather than codes, for example. And another example is, once again, so for the vaccines, the accuracy. So this is a very recent tweet 3 days ago. One guy published this tweet saying, look, I noticed that the reference target population of the category over 80s is continually changed. Okay, so now the latest one, the latest value is decreasing. Okay, it's decreased value with respect to what we had in March, but that is the reference target. So the question is, can we really trust this data? Because I think that you know better than me that we may have the most beautiful model, predictive model or something like that, but if we have garbage in input, we produce garbage in output. And I think that these issues are coming, are really coming a reality in this last year of our life, because the pandemic, COVID-19 pandemic, transformed more or less our lives in more data-driven life, if you think about that, because our freedom is based on some data, okay, and the analysis of data. So having good quality of the data can allow us to better also predict situations and you know, better face the phenomenon that that happen. So the idea that I was trying to push, I mean, for many years in the public sector, and that's why, and here comes the fact that I was not that successful, as I said before, is to try to think in a different way, try to manage our data in a different way, try to apply a paradigm shift, as I call it here, which can be completely different as we have now, okay? So the idea here is to use and to try to manage this data, taking into account the basic principles coming from the web. So if you think about the possible applications, most of them are based on the web, okay? And the web is based on open standards, it's interoperable. So why can we not exploit that, okay, in order to improve the situation that I have seen before? So the idea here is to, for example, promote the idea to have persistent URIs for things. So we can try to give URIs to things in the world so that we can give an identity to things and agree on identities of things, okay? So that obviously if we agree on an identity of things, we understand each other. So that's why we need that probably for semantic interoperability. And this is the mantra that I'm trying to say, from strings to codes, okay? So probably we can fix some of the issues that we have seen before. And if we have the web and we have uniform resource identifiers specified using the HTTP protocol, we should have also the possibility to differentiate these HTTP URIs and also provide mechanisms, you know, if you have different serializations and different formats, to have like some kind of content negotiation mechanism, so that depending on the application, you can get different data in different formats. Obviously, one of the main principles of the web, it is based on open standards. And so probably we need open standards in order to face also the interoperability issue that we have seen at the beginning of this presentation. And once again, with open standard, we can probably standardize the way in which we represent the data and in which we query the data themselves, okay? So that we can have a uniform way to do that. And another principle is that in order also to solve the problem of interoperability, we probably need something regarding some mechanism that allows us to have native data integration. So we link data to other data. Another important principle that is emerging a lot is to separate data from applications, because we need that at a certain point, especially if we want to let users to reacquire control on their own data. So in other words, what I'm saying in this slide, can we leverage the semantic web principles to try to fix the interoperability and data quality issues that we have seen before? Well, honestly, the answer is yes and no, I would say. Okay, in general, I can anticipate this answer, but then you can provide your you can provide me with your point of view. I think that the interoperability and the semantic interoperability issue can be target using this principle, definitely. I have seen real examples in where this can happen, okay? For the data quality, I have some doubts, because it is true that also the inventor of the web presented the semantic web, and the new paradigms regarding linking data as the highest quality that you can get in dealing with data. But I have seen also really situation and use cases in which also using these standards produce once again very bad quality data. It's a matter of culture, it's a matter of processes, okay, and the management of these processes that should be obviously revised. So when I speak about open standards, so I don't know the level of, probably you know already all these things. I don't know the audience also outside, but when I speak about open standards, I mean these standards like RDF, Resource Description Framework, OWL, Ontology Web Language, and SPARQL. Okay, so RDF is the standard for a data representation in the web. Okay, not on the web, in the web, immersed in the web. And so the data is in the form of triples: subject, predicate, object. And then you have that subject and the predicate as URIs, uniform resource identifiers. And the object can be values, like can be a string, like can be a date or a number, but an object can also have an URI. And when an object has a URI, means that it can be the subject of another triple, okay? Meaning that then we interconnect triples with each other, forming a graph, an interconnected graph, where, you know, the subject and the object are definitely the nodes of this graph, and the errors are the predicates. Then there is another standard, well, standard is not yet a standard. I mean, there is a process of standardizing it that is called RDF star, that allows you to predicate on the triples, because some in the community, in the research community of the semantic web, they started recognizing that representing the word as triples is not enough. So we need to say something on the triples themselves, okay? Like in this case, so you have subject, predicate, object, that is the triple, and you can attach like a predicate and object. This is RDF star indeed. And it is quite useful when you have to say, for example, that a specific statement, a triple statement, can have a certain level of accuracy, for example, or reliability, okay? So if you want to predicate something on that, we need something more. This is possible also to do with RDF. It's not, but this is a very compact way to say that. Then another standard is OWL, Ontology Web Language, that allows you to represent rich and complex knowledge about things and their relationships. So in a certain way, you can through OWL and through logical actions, define your word, okay, how it is represented, your word. We will see something later on in the presentation. And then we have SPARQL. So we have a graph, okay, we need to query the data that has this form, this triple form. And then there is this standard that is SPARQL, that is a protocol and the language both together, that allows you, as I said, to query this graph using this triple pattern matching principle. And then there is obviously SPARQL star that allows you to query RDF stars in the form that is mentioned above. So at the moment, there is this project that is called the Lot Cloud. That is, I mean, it's a reference project in the linked data community where they track the existence of this web of data, okay? So you can see the diagram. In order to be part of this project, you have to follow very strict rules in terms of quality. So I mean, in terms of the principles that I mentioned before of the paradigm shift, you have to comply to many of those principles if you want to be part of this project. So there are rules. You can browse also data sets. They are open, so you can definitely access to this data and use it, reuse it for many purposes. Okay, so the colors here regards domains. So as you can see, there is a hybridation of domains that are happening, and the black lines that you see are all the links that have been created. So you have like a very big database there based on web standards, okay, that you can query and get information essentially. Obviously, we have said before, so when I say that RDF allows you to represent data according to triples, subject, predicate, and object, where is the predicate? I mean, in all this story, and how can I specify the meaning of the data in this way? Okay, and here comes the role of the ontologies. Okay, and so that's why also there is the ontology web language in the semantic web stack. Okay, well, ontology comes from the philosophy field, but in computer science we mean a formal, explicit and shared conceptualization of a knowledge domain that is based on specific requirements that are to be collected, and then allows you actually to specify a set of axioms that define the entities and the relationships between these entities. In these slides, I put many examples of the ontologies available at the state of the art. There is a lot of work now at the European level for the definition of these so-called core vocabularies, okay? So that are, by the way, quite widely used in member states, at least in the North Europe. South Europe is still not so open to that yet. But there are some encouraging results coming also from the south of Europe, which is less data-driven. It's more document-driven, the south of Europe. But the north of Europe is already data-driven since years. There is the W3C that, by the way, standardized many of these ontologies. There is a very famous schema.org, which is the ontology used by Google to form its knowledge graph, the one that uses also to improve the search that we do on Google search engine and so on. So, and here there are some links that I put in this slide where you can find ontology. So if you are looking for models to model and to represent the knowledge, you can find a lot of information here. Not necessarily in OWL, okay, but it's a kind of good example of cataloging of this ontology. And when I mean with the ontology, I mean something like this. As you can see in this slide here, there is a person as sex. Sex is a class. and then lives in a location, okay, and the person has a date of birth. So by the way, this tool that you see here of graphical representation is a tool developed by the University of Bologna. There are some paper published on the tool itself that allows you to graphically represent the ontology themselves. So you can definitely draw something that is owl based, okay, in owl. The diagram on the bottom right, it's the instances. So it's the linked data based on that model of that ontology. So Giorgia Lodi is an instance, an individual is called of type person that has sex female, that lives in Rome, that is a location, okay? So, and the union of ontology and linked data is what we call, at least in our laboratory, knowledge graph. In the literature, there is no a uniform definition of what is a knowledge graph, but we mean this when we do our work, okay? And another example, I can tell you many things about this work. That is the work that I have done in the last 4 years, I would say. So if you are looking for already available data models that allows you to represent knowledge, you can find it in Italy. There is a GitHub repository of this framework that is called Utopia. So it recalls utopia of the title of the slide, obviously conjugated to in the ontology work. So what we have created here, we have tried to, represent the knowledge that is in the public sector of our country. So we created the 30 ontologies, 40 controlled vocabularies, where controlled vocabularies means for us a list of codes and labels, okay, that can be complex or simple list of code and labels, or more complex like taxonomy. But these are the controlled vocabularies that we created, also according to official classification coming from our National Institute of Statistics. And with this work, we have defined more than 15,000 logical axioms. Probably there are more, honestly, because this data probably is quite old. But you can see in this slide the organization of this framework. So we have very vertical ontologies specific to a specific domain, like can be the accommodation or the cultural heritage, or the parking, or the public events, or the public services. We have also modeled something regarding the higher education and research domain. So in that ontology, there are concepts regarding projects, research projects, the university system, okay, with student and academic roles. There are clinical trials are there modeled. By the way, we heard a lot about them over this period. Then we have other ontology, ontology that we call core, like person, organization, location, addresses, because once you have modeled these main building blocks, then you have modeled a very lot of pieces of data that you have probably in databases. And then there are some supporting ontologies that support the domain ontology, that use the core ontology and that add additional things. Everything is organized in a network through, let me say, it's not really a foundational ontology, but it's a top level ontology. So an ontology that is formed by very abstract concepts, okay, really close to the philosophy, okay, that allows us to keep all this ontology all together organized in a network. By the way, this ontology that we call it with no many fantasy here, L0, so the first level that we have, it's fully aligned with the important foundational ontologies that can be found at the state of the art. I don't know if you ever heard about Dolce or Dolce ultralight ontologies that allows you really to reason at a very high level of abstraction of the work. So when we do that, we apply a process, okay? We apply a process that is here represented in this slide with the steps that we do. And we apply some methodologies that have been also published. Here you can find some reference papers. So first of all, we collect requirements, okay? That can be in many different forms. It can be data sets, it can be domain experts that are there with the modelers who tell the story of the data, of the domain that has to be represented. And so we collect then user stories and so-called competency questions. So competency questions are questions that you want to pose on your data, and so you want to verify that your model is sound enough to be able to query the data in that specific way. That is not, it seems trivial, but it's really not, to be honest. Obviously, in parallel, we also analyze existing ontologies, especially what we wanted to do is to see whether something already exists. Or what we also want to do is to identify what we call ontology design patterns. And I will come in a few minutes in this, on this point. Then we modularize. So all the ontologies that you have seen before are modules, okay? Because when you modularize, it's like in software developing and software engineering, you create modules so that it's better to maintain over time the evolution of the model. Then you have to decide if you want to reuse directly or indirectly ontologies. Here there is a lot of discussion in the research community. We published, by the way, an article where we explain the fact that to reuse directly, so you take a piece of an ontology already existing, you put in your ontology, or you can align it. So link once again to an external one saying, look, my concept is somehow close to the other concept defined in the other ontology. Then we produce data. We do some testing against the competency questions collected at the beginning, and then we do refactoring of the knowledge graph that we produce, because there are sometimes issues when we transform the data that you have. For example, one of the issue is the fact that probably you have, let's take this example, you have address like via San Donato. Okay, Bologna, okay? Or you have another occurrence of the same address, but it's written via S. Donato, Bologna. So if we translate the data from the original set to the RDF, it's the same. I have two individuals, one for San and the other one as Donato. And we need to recognize that they are the same, for example, concept, so that we have to collect them in one unique uniform resource identifier. This phase is called entity deduplication, okay? But there is also the other problem. So you have probably in other cases, you collapse something in one uniform resource identifier, but they are two distinct individuals, and this is called entity disambiguation. And then we link, because one of the main strengths of this approach is linking the data to external data set of other organizations, for example, because you want in this way to enrich your data with additional data that you can find outside. And then obviously you arrive to produce the knowledge graph. As I said before, there is one step fundamental in our methodology, that is that we believe it's the real point when we model the knowledge to have and to guarantee semantic interoperability. The idea here is to reuse as much as possible so-called ontology design patterns. It's the same concept that is behind once again, software development. Even when you develop software, you have design patterns, okay, that you can reuse. The same applies here. So design patterns are typically already available modeling solutions for problems that are recurrent in the modeling world, okay? And there are some research, once again, and there are some papers here in these slides that prove the fact that reusing ontology design patterns help in detecting, help obviously to reduce the modeling errors. This is definitely true, and also help in detecting requirements that are not so evident probably at the beginning. Overall, it was noticed that the data produced, having modeled the ontology behind with ontology design patterns seems more sound, okay? So ontology design patterns are something like this. So you have this, for example, this is an ontology design pattern, or one of the most used, I would say, design pattern to model things that change over time, okay? That is not quite common to find in databases, okay, or in data sets. And here you have like a situation in which you have that for some entities, you have an interval, okay, time interval associated to that, and you specify that situation for something, okay. So this design pattern can be then applied to your domain that you are representing, obviously. In this case, in the second example, there is that pattern applying to roles of agents in public services or in any kind of services. Okay, so you have this situation, a time index role situation in this case, connected with the time, connected with the service, connected to the agent and to the role itself. So once we have done all of this, one of the most important things that we have is that we can do inference of knowledge, okay? So if in the schema you have something like in this slide, so you have like, you define a concept, a class, that is the class musical artist, you can say that that musical artist is equivalent to what? To a class artist that plays some music, okay? So if in the data you have this example where you have Miles Davis, which is an artist, that plays jazz, and jazz is a music, then you can infer the fact that Miles Davis is a musical artist, because in the schema you have defined that logical axiom there that says something like that, that musical artist is equivalent to that axiom. And this is quite powerful, okay? So in the sense that you can in this way discover new knowledge that probably you don't have in your data, and you can infer something to discover new knowledge. So what we can do with all of this, okay? Can we fix the problem that we said at the beginning? I would like to tell you, to conclude this presentation, some real examples in which we can probably appreciate the benefits of having what I have now explained to you. First of all, we can definitely use this knowledge representation, which is common and shared, in order to create interoperable federated systems, for example. So if we have different systems, okay, we can, for example, create a central unique access point of these systems that, based on that knowledge, a knowledge graph represented in a certain way, you can get information from all these systems that are different with each other. We are not obliged to use the same, exactly the same technology, okay, to have interoperable system. We can have different technologies, but we can, using a common model, using a common representation of the knowledge that we have all together for something, we can definitely communicate with each other. So the initial problem of the interoperability probably can be faced with that. Examples of this kind of system, one is Google data search, for example, but the European data portal is another example, a real example of system working in this way. Also, our national catalog of data is working in this way. Another way to get benefit of that is this project that we have, my laboratory has with the Ministry of Culture. For the Ministry of Culture, we produced a knowledge graph that is called ARCO. There are these 169 million and blah blah triples, and we link to 20,000, more than 20,000 distinct entities coming from external data sets in order to represent the knowledge, the cultural heritage knowledge of our country, okay? So they are here in this project, both cultural sites, physical objects, okay, so physical monuments and something like that, and also small objects and movable objects that are inside this cultural site. And using this graph, the ministry opened a tender, okay, that was, by the way, assigned by a consortium of enterprises, Italian companies, and they developed this catalog, okay, that is more or less an example, a real example of the system of the slide before, where you can navigate all these cultural heritage properties, okay, in a different way with respect to the past, because now you can have more controlled searches according to the represented knowledge, okay, so that you can go as a user, you can also get more quickly probably the information that you are searching for, okay? And then there is also another nice thing of this catalog is that when you navigate things, you can see also other resources that you don't have in your own system, that the ministry doesn't own, okay? But are coming from the linking that are here with external resources. So there is an enrichment of this data that we have in Italy with other data available in the web of data that can be used to enhance the user experience. This is another example of a project that is finished, a robotic project, okay? So it was a project funded under the Horizon 2020 program. It is called Mario. It's a robot, okay? And so in this case, what we did is to create a network, once again, of ontology, of ontologies regarding, in this case, the life events of people, elderly people, okay, that were involved in this project, because the project was to create a social robot that could be, better to say, a companion robot that is able to provide, you know, these elderly people with very preliminary they have some problems in terms of remind things, okay, with memory, and so the robot wanted to with some applications that were developed, wanted to, you know, keep the memory of these people always active, so that they can understand, remember something, especially in their life when they were young. And so we used these ontologies and this knowledge graph that was then created based on this network of ontology of these people, and then we created applications that, using that knowledge graph, could interact with the elderly person in front to the computer. Another thing, this is a PhD student who is currently doing that, is to use the knowledge graph to navigate within virtual immersive environments, okay? So in this case, essentially, if you think to a virtual environment or like virtual reality, okay, so you can navigate within some sites, okay, of our cultural heritage, and every instance of the virtual environment is an instance of this knowledge graph, basically the knowledge graph that we have seen before, this ARCO knowledge graph of the cultural heritage. So we leverage the knowledge graph and we provide information to a person that wants to do this immersive route within some knowledge. Another point, what we can do with knowledge graph, well, we can break data silos, okay? So because one of the point is that to link data, okay? And so this is another project that is currently ongoing. I'm definitely involved in this project. It's not an Horizon 2020, is funded under the EU program CEF Telecom, that is, by the way, finished as Horizon. In this project, what we want to do is to create what we say the first knowledge graph in Europe on water, both marine and inland waters, and health data. So we want to see if there is possible link between these two different words, two different domains, so that to help others, because here we are speaking about open data, help others to understand if there are possible correlations between these two different words. There is, by the way, a co-creation program that is part of this project. So here we want also to create a community behind that, both technical community on one end, but also very domain-oriented communities interested in water, but also health data. It's open, by the way, if you want to collaborate with us, it's possible. They are Italian partners mostly, apart from the coordinator, which is a company located in Ireland. So that's a nice possibility, okay? I hope that you enjoyed all the possibilities that we have using knowledge graph and using the knowledge representation. However, the world is definitely not perfect, okay? And there are still many missing points and many issues to target. I mean, what I have described typically fall under the so-called symbolic artificial intelligence, okay? So there are many people saying, you know, the effort required to create all this representation of the knowledge is so huge that we cannot definitely afford it. That's probably true. I mean, I have on my shoulder, I have many experiences also of complaining with many people regarding how to model things. But definitely there is also a lot of work already done. So as I said before, also with Utopia, we have a piece of work that has been already represented. Obviously, the world evolves, you have to let these models evolve, so it requires, obviously, effort. Not only that, but what we still notice is that in knowledge graphs available, there is still a lot of hidden knowledge with unstructured text. And definitely the data quality is not that high sometimes, because there are some issues here of data quality. For example, there are some knowledge graph, also the one of the cultural heritage that I have mentioned before, where some data that can be helpful are definitely missing. So one of these problems can be fixed, okay? Or at least we can use some tools that we developed in our laboratory to try to target the hidden knowledge, okay? So we can try to extract knowledge from this unstructured text. And during years in the laboratory, we have developed this tool that is called Fred, that is able to read a text in natural language and then derive from it a knowledge graph, okay? Here you can see an example of that. By the way, there is a link of this tool. You can use it. I think there are also APIs that you can use it if you want. So this is a sentence: the President Joe Biden decided to stop vaccinations with Johnson vaccine. And so this is the graph that represents this sentence, this unstructured text. It's not very probably readable, but with the slides you can see it. I mean, the nice thing of this tool is that it's a knowledge graph, so meaning that it is both ontology and instances, and he recognized many interesting things. For example, Joe Biden has been here, if I remember correctly, here is Joe Biden, that is president, okay? It was linked here with DBpedia Joe Biden instance. So he recognized that the Joe Biden here is the same Joe Biden that is contained in the DBpedia dataset, which is the datasets linked open dataset coming from Wikipedia. And he recognized that he's a person, by the way, using schema.org, which is the Google, I said, ontology used by the Google Knowledge Graph. But then there are many other things like that in Fred. So if you want to read, this is a paper of that. What we are also doing, and then I'm concluding my presentation. This is a PhD student, by the way, of the laboratory, is doing this work because, as I said, we recognize that there are some missing data, okay? And so what we wanted to do is to try to cover and to the knowledge, okay, in our knowledge graph using machine learning, okay? So in this case, you can see this cultural property. We noticed that in the cultural heritage knowledge graph, there are elements with no property icon classes code. Okay, so the icon class, it's I mean, it's not really relevant, but there is like a classification available at the state of the art that allows you to classify these objects according to some themes. Okay, let me say. So here there is no data. So the idea is to let something automatically create a code that is associated to that object. And to do that, we use neural network linear classifiers, okay? But we use, to training it, the entities in our knowledge graph that have that code, so that to learn and to apply this technique in order to, you know, complete the data that is not complete. So here there are some examples. They just started with some training. It's data encouraging data, let me say. And this is a way, you know, to put together symbolic and non-symbolic artificial intelligence. So to conclude that, because probably we are very close to the end. So first of all, let me say, I've been working with this knowledge representation and knowledge graph since years. I saw they are getting a momentum, okay, now. This is also documented by Gartner. If you are familiar with that, with the hype cycle, they appeared just 2 years ago, I think, and they are, you know, considering something to be used. And I definitely see that the industry is moving to this field. I mean, they are using a lot of that knowledge representation, at least in their internal organization. Also the public sector. In Italy, not so much, but I presented you some example. But definitely there are other countries like Belgium that are entirely based on linked data and also linked open data, okay? Another trend that there is pushed by the inventor of the web, Tim Berners-Lee. There is this new project, I don't know if you have heard about it, that is called SOLID, social linked data. And what they want to do is to, as I said before, separate data from the applications so that you as user who owns the data, you decide to which other organizations or other people share the data, so that you have full control of your data. And this open a lot of things regarding privacy preserving applications. And there is also the developments that I'm discussing with some people to separate data from the application, but also rules from the application. That was quite important also in the context of COVID-19, where rules, especially in the public sector, when you have a process, change very frequently. And once again, I think that what I wanted here in this presentation to show is that I think there is this higher interest in combining neural and symbolic artificial intelligence. Someone say that there is a third wave in artificial intelligence where all these things can be combined together. There was an example before, but you can also use it in the other way. You can have machine learning, you can do classifications, so you rank the result, and you can use knowledge graph to help in ranking your stuff. And obviously, we are here open to any possible collaboration, as Annalisa said at the beginning, also taking into account that there is a new Horizon Europe funding program. So really, let's try to see if there is space for collaboration. Thanks a lot, Annalisa, for this invitation. And if you have any question, I'm here.
Thank you, Giorgia. Any question? I'm not sure I see all participants. Yeah. So I have one, actually. It's more a philosophical question. Can you hear me?
Yes.
Okay, good. So yeah, I'm very naive regarding everything you talked about, because I'm really wondering. I'd like to see the advantage of machine learning people helping the process that you described, because I clearly see the other way around. So I think that if you come to a community of machine learning and you present this data well organized, as you just presented before, so it's a bunch of data which is possibly a big large scale data, and also well organized. So there's this ontology that's describing the data and the relation among the variables and so on and so forth. That's a big gift to a community like us, in the sense that that's prior knowledge that we can incorporate in the algorithms to infer possible new knowledge. What I'm always wondering about is how can we do, how does it work in the other way around? So how machine learning can sort of help the construction of the ontology, and how would you manage the inevitable uncertainty that comes with our kind of answers? And we are not in a, like machine learning in general, or actually the one that I'm used to is definitely noisy. So, and I think what you described is not. So how does it work?
I don't know. I mean, it's a nice question. I mean, I think it's really something that the communities of both sides, okay, are trying to investigate, okay, so try to merge these approaches. I mentioned before the example of completing the data of the knowledge graph using machine learning. So let's try to use neural network, okay, classifiers in order to try to automatically deduce something, okay, that based on the data that we have, okay, that is a possibility, to be honest. Another point is that obviously I come from one of the community, let me say, of knowledge representation, and definitely I can tell you that we are using machine learnings, and then we are trying to help ourselves with the machine learning results, helping with the structured knowledge to better refine the results obtained from machine learning stuff. So yeah, indeed, it is true that also indeed from the machine learning to the knowledge graph is simple to say, probably to see, probably, but I think there is also space on the other way around. And I would also say one important point that you mentioned, Annalisa, was to you mentioned the fact to probably automatically create ontologies, okay, or something like that. That it would be a very nice thing to think about, because indeed, if we want also to target that huge human effort required to represent the word, we can help ourselves using that. And for example, we have like a lot of ontology design patterns, okay? And so we have already ontologies. We can probably understand and train things and try to see if other techniques in the artificial intelligence field that can allow us to automatize some way. Then probably you need in a certain way some human intervention to refine things, okay? But yeah, why not? Indeed, that could be a nice thing in collaboration if we can do it, definitely.
We have thanks. We have a couple of questions from the audience. So one is, could you comment on how this relates to the FAIR principle guiding open data sharing in research? Is this a way to implement FAIR principle and achieve interoperable and reusable data also in interdisciplinary research?
Wow, how many questions? Okay, so in one, okay. Yeah, I mean, I read very recently that the FAIR principles are really all, how to say, really all met only if you have linked data. Because if you think about it, FAIR principle are foundable, accessible, interoperable, reusable. Okay, so reusable means that you can reuse them, means probably open data, but findable, accessible, and interoperable, okay? The linked data paradigm is definitely totally in line with this, because findable means that you have to indicate metadata to let this data discoverable, okay? And you have to do the metadata according to the principle that we have seen before. So URIs, persistent URIs, and so on. So the basic principles of this knowledge graphs and knowledge representation are all absolutely the building blocks, let me say, for the FAI word of these FAIR principles. So, and as I said, I read one person from research saying, I never seen other type of data sets that are FAIR apart from linked open data sets. So it's easier to say that a data set is FAIR with the linked data, because as I said, linked data are based on the concept of findable, accessible, and interoperable. But I'm sure that also other type of data can be done like that. I mean, if I think also to JSON data sets and so on, if they are open, if they are, I mean, correctly created, I think they can do that. And the second question is this a way to implement FAIR principle and achieve interoperable, reusable? Yeah, I think so. I definitely think that this approach can definitely help in achieving that.
Okay, there's another one actually on the adaptability on the ontology. So how difficult is it to update the ontological categories? And how you manage adding new ones, for example? How do you do that?
Okay, so if I go back to this slide here, okay, this slide, okay, can you see here this Nomad CT? This is an ontology, a very famous ontology in the medical world, okay, and they are. I have followed a talk recently saying that there are more than 300,000 medical definition inside that, and they took 40 years to arrive to an agreement between the communities in the medical sector to create that, and every year there are 10,000 or something like that updates of that ontology. So once again, the human effort to update that, it's important. But I would say that one step of the methodological approach that I presented, so modularization, definitely help in maintaining these ontologies and the evolution of these ontologies over time. Okay, typically when you create an ontology, you define a very well-defined change management process. At the European level, for example, they define that minor changes can happen quite frequently, but then after 2 years, because you cannot change the schema continuously, otherwise the people cannot really use it in representing their knowledge. But after 2 years, you do like an evolution. It's something that is affordable, I think, in general, especially if you apply the methodologies, the good methodologies that allows you to maintain over time these digital artifacts, let me say. But once again, I would like to say something. I presented that methodology. I have seen ontologies also created by people, okay? There are some ontologies that are terrible from my point of view, that do not follow anything of the best practices and what I have described, okay? And that is even more difficult to maintain over time. So if you follow like ontology design patterns, you modularize stuff, it's easier to maintain, but definitely some human effort is required, yeah.
Okay, thank you. Any other questions? I don't see any more questions on the chat. Okay, so we thank you again. We're very happy. It was a very interesting talk. So yeah, thanks. And yeah, thank you very much from everyone. And okay.